rating and current rating of an silicon controlled rectifier, that is nothing but one of the important member of a thyristor family. To use SCR in a faithful condition, it is very much essential that we should take care of that it should not cross the limits provided by the manufacturer in case of voltage and current. So same way, we have to take into consideration the power rating of thyristor also. In case of power rating, as I explained, in case of voltage ratings are important when thyristor is in off state or in reverse blocking state, whereas current ratings are important when transistor is in on state, because in case of on state, current flows maximum, whereas in case of off state, voltage across thyristor is maximum. Now in case of power, either of these things, because power is a product of voltage and current. So if either voltage is greater or current is greater, power is going to be more. So while considering the power rating, we have to consider both these cases, that is on state as well as off state. So power ratings are basically classified forward conduction, then turn on switching, forward and reverse blocking, and gate pulse triggering. So in case of forward conduction, the current is maximum whereas voltage is minimum. So the total power loss P is nothing but V into I. Whereas in case of turn on switching is nothing but it is a power loss when transistor is switching from off state to on state. In this state, though the time is very small, that is turning on time required to thyristor to turn state from off to on state is very small, that is in terms of microseconds. But in this case, as in between transition, the voltage is also maximum, current is also maximum, so we have to take into consideration this turn on switching also. In case of turn off switching or commutation, it is nothing but a process of converting or switching the resistor from on state to off state. So it is nothing but a commutation. In this case again, while switching it off from on state, voltage is maximum as well as current is maximum. So this power rating also to be taken into consideration. So it is nothing but the maximum power which can be dissipated safely by the SCR in case of turning off from on state. In case of blocking states, forward blocking as well as reverse blocking. In case of forward blocking, the anode is positive with respect to cathode, junction J1 and J3 are in forward bias and J2 is in reverse bias. Whereas in case of reverse blocking, opposite is the case, anode is negative with respect to cathode and junction J1 and junction J3 are reverse bias, whereas junction J2 is in forward bias. But in both these cases, current is not flowing. The current which is flowing from anode to cathode is very small. It is very small amount of current which is also called as a leakage current, and whatever power loss is because of the voltage across thyristor which is maximum. Then last one is the gate pulse triggering. So this is nothing but the losses which are occurring across the gate terminal. So as we know that the current which is flowing from anode to cathode can be controlled by controlling the gate signal. So different signals we can apply at the gate. We can apply DC, we can apply AC as well as we can apply pulse. If we are applying DC, we are applying the signal continuously. Unnecessarily we are wasting the power, so it is nothing but the power loss. Then in case of AC also, we are losing some amount of power, whereas pulse triggering is preferred because it consumes less power, as we can apply a pulse of very short duration, that is low duty cycle pulse with sufficient amount of magnitude can be applied to the gate to turn on the thyristor from off state to on state. So the next topic is the turning on methods of a thyristor. So here the different methods which we are going to study, which are used to turn on SCR from off state. So SCR can be turned on with different methods as I discussed earlier, that is, one is forward voltage triggering, another is thermal or radiation triggering, then light triggering, then dV by dt triggering and gate triggering. In case of forward voltage triggering, we can turn on the device by applying a voltage across anode to cathode, that is a forward voltage across anode to cathode, which is greater than the breakover voltage. In case of thermal triggering, SCR can be turned on with the help of increasing temperature if SCR is near to the breakover voltage, means it is applied with near to breakover voltage VBO, and if we increase the temperature, then as it is made up of semiconductor material, the sensitivity or the charge carriers across reverse bias junction J2 will increase, which will break the junction and device can be turned on. In case of light triggering, which is a special case of light activated silicon controlled rectifier, we can turn on SCR by bombarding light on a junction J2, which makes junction J2 forward bias, and already we had applied a forward bias across anode to cathode. So this way also we can turn on the SCR. Then dV by dt, as I told, dV by dt is nothing but it is rate of change of voltage applied across the anode to cathode with respect to time. Now, if we consider a PN structure as junction J1 when it is forward bias, when anode is positive with respect to cathode, junction J1 is forward bias and junction J3 is forward bias, which acts as the two plates of capacitor, and junction J2 which is reverse bias can be considered as a depletion layer between these two plates. So total is nothing but it produces a capacitive effect, and if rate of change of applied voltage across capacitor changes, then the current flowing through capacitor will increase, which is proportional to the dV by dt. So this way also we can increase the amount of current which is flowing through reverse bias junction J2, and we can turn on the thyristor. So P and PN will be going to be forward bias, and it will flow, or current will flow from anode to cathode. The most efficient method of turning on the SCR is by applying a gate current, as already discussed. So in case of gate current, we can apply DC, we can apply AC, as well as we can apply pulse. The methods which we had already discussed of turning on the SCR from off state, the forward breakover voltage, dV by dt triggering, light triggering, thermal triggering, these methods are practically difficult, whereas the most efficient method, practically used method, is nothing but gate triggering method. So let us discuss the different types of gate triggering methods. So gate triggering methods which are effectively and efficiently used in case of triggering of the thyristor means nothing but in the process of turning SCR on from off state are R triggering, that is nothing but resistance triggering, then RC triggering, which is also called as resistance capacitance triggering, and the UJT triggering, that is unijunction transistor triggering. Means by using either R or RC circuitry or by UJT relaxation oscillator, we can turn on the SCR. So let us discuss one by one.